Hi everyone, my name is Fatin Aqilah binti Mahmod and my partner is Nurul Izzah binti Zaid. Our project entitled the Automated Soy Sauce Temperature Control Monitoring System using Labview. For the introduction, this project is using system engineering software for the application that requires test, measurement and control, which is Labview software. Soy sauce is a liquid condiment made from a fermented paste of soybeans, roasted grain, and many more ingredients. This project aims to decrease human efforts and also the human error in soy sauce production. The working principle for this project is to control the water level, temperature monitoring, and cooling process. Let's proceed to the methodology. This is our system design, where the input is an ultrasonic sensor as an indicator to indicate the level of the soy sauce, and the other one is a water temperature sensor to measure the temperature of the soy sauce in the tank. Labview as the serial interface with the SCADA. Next, for the output, we have two outputs, which are the solenoid valve and cooling fan. The function of the solenoid valve is to open or close the inlet and the outlet valve. The function of the cooling fan is to on when the temperature is high until the desired temperature. For the flowchart, when the process is started, the inlet valve is opened to fill the soy sauce into the tank until it reaches 50 liters. Then, the solenoid valve will be closed. If not, it will continue open until it reaches the desired level. Next, it will measure the temperature. If it is more than 29 degrees Celsius, the cooling fan will be on. After it reaches the 29 degrees Celsius, the fan will be closed and the outlet valve is open to be distributed to the pipeline. The process will be end. In the PID diagram, we have three loops. The first one is for the level transmitter to measure the level of the soy sauce in the tank. The level controller will be triggered to open the input valve. Next, for the level transmitter, the temperature controller will trigger the motor to on when the temperature is high. The last one is the level controller to trigger the outlet valve to be open.
Okay, for the block diagram, we are implementing 3 PID controller for 3 loops of process using PID algorithm for simple PID applications that require an efficient algorithm. The PID algorithm features control output range limiting with integrator, anti-wind up and bumpless controller output for PID gain changes. The output will connect to the input of plant system. The output saturation range were set 100 and 0. The process parameters connect to the output cluster. This function refers to cluster elements by their position in the cluster. So this is the Boolean equation for inlet valve. The range is between 0 to 49. It will trigger inlet valve to on. And then the soy sauce will fill into the soy sauce tank. While for second PID controller, when the input range is between 29 to 89, it will trigger cooling fan to on. After that, for third PID controller, the output is outlet valve. When the input range is between 0.5 to 49, it will trigger outlet valve to on. This is the front panel of the automated soy sauce temperature control monitoring system using Labview. Before we run the simulation, set point for inlet valve was set 50 liter, and then set point for temperature is 90 degrees Celsius. And lastly, set point for outlet valve is set to 50 liter. When we start run the simulation, the inlet valve will on. Soy sauce will start fill into the tank until it reach to 50 liter. And then temperature sensor will start measure the temperature. When temperature is 90 degrees Celsius, the cooling fan is on for cooling process. While when it reaches to 29 degrees Celsius, the cooling fan will be turned off. Then the outlet valve will open and ready to distribute for the filling process.